In this math workshop, we will examine math routines as a key tool in our math toolbox of strategies to support our students. We will share what they are, why we should facilitate them, when to facilitate them, where and how. Whether you are an educator new to teaching math, a homeschool parent teaching your young mathematician, or a parent interested in supporting your child, or an experienced math teacher, our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. What are math routines? Math routines are a daily 5 to 15-minute routine. They are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency. The teacher's role is to provide the math routine and to facilitate the discussion. Teachers do a lot of listening and learning about their students' mathematical understanding. The student's role in math routines is to think, reason, share, and learn from each other. They're honestly our favorite part of math class. This comes from educators, students, and myself. What are some math routines? Well, just to name a few, number talks, subitizing, quick images, which doesn't belong, tell me all you can, visual patterns, array images, same and different, guess the rule, and share your solution. And there's more, but those are just to name some. When should a teacher add math routines to their schedule? Math routines are a great way to warm up students' mathematical brains at the beginning of math class. They're naturally a great transition because students love to engage in them. I remember a first grade classroom that I was coaching in a while back, and the first grade teacher had students meet at the rug right after recess or break for their math routine time. And I was just so impressed with how eager the students were to get back inside, get settled quietly on the rug. They were so excited to participate in their math routine. Conversely, math routines can also be implemented at the conclusion of math class as an exit ticket. Students could record their responses in a math journal, on a post-it note, on a note card, on an individual whiteboard, or simply do a turn and talk with a partner. Maybe there's an odd 10 minutes in your class schedule for the day in between specials or subjects where a math routine would be perfect. Honestly, there's no wrong time to engage your students in a 5 to 15-minute math routine. Parents even love to see math routines modeled with them themselves at back to school nights. Where to engage your students with math routines? The answer lies in your particular situation and space. Educators take their physical space, their classroom, into consideration, whether they're gifted to have a large whiteboard projector and if they have a rug where students can meet as a mathematical community, knowing they're just going to be there 5 to 15 minutes. So it's not too long, short and sweet. Additionally, teachers may want to consider what math tools would be valuable to be posted near that area, wherever they're going to have, where they're going to facilitate their math routine. For example, in kindergarten, I've seen teachers, of course, kindergarten teachers always have a rug. They'll have a large number path posted easily within view of the kindergartner's eyes to support their time in the math routine. Also, in second grade classrooms, I've seen teachers post a large 100 chart nearby the area where the students were engaged in math routines. So I know teachers just consider what visual representations or models might support my students thinking and being successful during this math routine? Educators want to consider how where they facilitate the math routine impacts their students' ability for communication. Um, because we really want to foster students thinking and as they're sharing with their classmates and listening to their classmates. So sometimes teachers don't want their students back at their desks where they're more spread out and where they're more likely to fiddle with things inside their desk and not give their full attention to the discussion that's taking place during the math routine. But honestly, teachers really have to think about their space and what works best. How to facilitate math routines. Well, there are nuances within particular math routines. We have more math workshop videos on the various math routines that we have on our website, themathworkshop.net. So, for example, with quick images, which are in essence a type of number talk, we only show the image to students for about 3 seconds, and then we hide the image. And the reason for this is because we're trying to gently influence our students not to count the items on the screen, but to see the groups of items. This is called subitizing. Each math routine has its own slight nuance, but in a nutshell, all math routines should be short and sweet. They should happen daily. That's why they're powerful, because the benefits collect over time for students and their understanding. And now let's look at some examples of some of the math routines that we can provide for our students. This is an example of a quick image. So you see dots. Students would be shown these dots for about 3 seconds. So you're seeing them for a lot longer. And they would be asked to consider two questions. First, how many do you see? And then, how did you see them? And again, we have more math workshop videos that dig deeper into each math routine, but this is just an overview. So some students might say, I saw 4 and 4 more, and I knew that made 8. So the teacher is the one doing the recording, listening to students. And the teacher might ask, who else saw it that way? And sometimes teachers teach their students the sign language, which means me also or me too. Essentially, I saw it that way too. It's a quiet way, for a nonverbal way, that the teacher can look around and see who else saw the 4 and 4. But then the teacher asks a wonderful follow-up question. Who saw it another way? I love that question because it's really a positive supposition that there are other ways to decompose this 8. So by asking it as who saw it another way, it's really inviting students to go, oh, there must be other ways. So then maybe another student might say, oh, I saw 2 and 2 and 2 and 2, and that makes 8. And again, the teacher is the one who's quickly recording, possibly, if the teacher makes that decision. Probably an early beginning of kindergarten, teacher might not be recording yet. They're just warming up the kids, getting used to this routine. Definitely later in kindergarten, the teacher's going to be recording these, the groupings and recording with equations and the numbers. And upper grades are probably, it's more, they should be doing that too. And again, the teacher's going to say, who saw it that way? And other kids might be doing the silent sign language for me too, that you would teach the class. And again, the teacher's going to ask that follow-up question, who saw it another way? Or even if no one says they saw it another way, you could say, push them and say, can you push yourself right now to see it another way? And still some other students might say, well, I knew it was 8 because 1 and 1 make 2, and 3 and 3 make 6, and 2 and 6 make 8. And depending on the age of the students, again, teacher may want to record that corresponding equation and name the strategy. So that student was adding by doubles. So by naming the strategies, we can empower our students to now have this common language, because 1 and 1 make 2, 3 and 3, 6. Those are doubles. And knowing the names of strategies can be really powerful for students to be able to make connections with each other and be able to use that strategy again. So the superpower of quick images, and quick images honestly can be used K through adulthood. The superpower of quick images is that students are seeing all the ways that a number, and in this example, it was 8, can be decomposed or broken apart. And on this slide, we're seeing 3 examples from students, and there are others, but we're looking at 3 examples. And this is a very important idea, that this subitizing, where students are seeing groups within a larger number, what sets make up that number, can make up that number. This actually begins to lay the foundation for success later in algebra. Now, it's really important that the dots, for using dot images for our quick images, that they're very strategically placed in purposeful ways. And there are resources out there for you on what dot arrangements seem to elicit groupings. So we do have more information on our website about this. So I would encourage you to explore that if these dot images, these quick images, are new to you. Let's look at another math routine. This one's called Which Does Not Belong. And in this math routine, the teacher usually shares a collection of 4 items. It could be numbers, shapes, photos, or pictures, sometimes words, and asks the students which does not belong, and asks the students to think about why. Why does it not belong? So here's an example of a which does not belong. It would be appropriate for kindergarten, maybe first graders who need to revisit some early numeracy work, or, let's be honest, there's going to be other students in other grades that perhaps for a multitude of reasons, some foundational mathematical ideas were not in place, that this would be beneficial to continue to work on. I'm going to pause so you can consider, out of those 4 10 frames, which does not belong and why. Some students might say that the top left 10 frame doesn't belong because the 5 red counters spill over into the 2 rows. So we see 4 and 1. Whereas in all of the other examples, the 5 is in a consecutive row. Some other students might say that the bottom right example of the 10 frame is the one that doesn't belong because all of the red counters are on the bottom row. And for the other examples, mostly the red counters are on the top row. Both responses are acceptable. The beauty of all math routines is that the thinking and the reasoning comes from the students. If you don't get responses that you think are really digging that deep, revisit the image later, another week, another month, come back to it another time. This is not really a time for you to teach or to show your thinking, because honestly, I think we've seen as educators, that doesn't stick with kids. So revisit this another time, and maybe your kids are further along in their thinking, and then they might see what you were hoping in your mind they would see. In a lot of examples of which does not belong from various educational resources, you're going to see an A, B, C, D labeling. We intentionally did not label our collection of which does not belong because we strategically wanted students using positional words, which are in the kindergarten math standards, next to, above, below. So we want to give students that opportunity to use that kind of language. So they might say the top left, the top row, the bottom right, and so on. Here's another example of the math routine which does not belong. Which one do you think doesn't belong? Did I give you enough time? These are pattern blocks. And as a side note, you're probably going to want to have, I would say, really for all, I would say K through 6 should have pattern blocks because they're foundational for kindergarten, first grade, second grade, for shapes, talking about different characteristics and attributes of shapes, but also fourth, fifth, and sixth grade can use pattern blocks to work with fractions. And if you watch our videos that we have on our website or on our YouTube channel, we have a math tools video for fourth, fifth, and sixth grade that touches on this. So which one did you think didn't belong? Oh, and one more side note is the graphics that I'm using on this slide, you can access for free on the Math Learning Center website. They have interactive tools, which are a great way to model the tools, these manipulatives you would have in your classroom. All right, let's get to the answers. So some students might say that the yellow hexagon on the bottom right corner doesn't belong because all of the other options are either a trapezoid, the red one, the red shape is a trapezoid, or they're making a trapezoid. The shapes are composed together to make a trapezoid. Other students might say that the green triangle and the blue rhombus in the top right doesn't belong because it's the only option that has two colors, whereas the other options just have one color represented. Both answers are completely appropriate, and students would be using reasoning to come to those conclusions, and there could be more answers. Those are just two. Here's a sixth grade example for which does not belong. In this example, the pinkish purple rectangular array is the only choice that doesn't represent 9. The superpower of the which does not belong math routine is that the options we present to our students should have multiple answers. They don't always work out that way, but most often they do. And that's really the beauty of it. So that takes thoughtful consideration on our part to design problems where there's multiple opportunities for reasoning. Next up is array images. With this math routine, the students will be shown an image and asked to consider some questions. The teacher should consider if math tools like manipulatives or grid paper, maybe individual whiteboards, would that be supportive to students' thinking and exploration during this math routine? And it's going to depend on the image each time. Depending on the time frame, the teacher will also adjust the number of questions explored. They will invite students, either independently or with partners or in small groups, to generate equations that match images. And possibly, if there's time permitting, students could do a gallery walk, viewing different students' equations, or pass the paper to examine equations to compare the equations. The images in this routine, though, I wanted you to know, are not intended to be flashed like the quick images routine. So we're just going to look at them and keep them up and be comfortable with them and see them. With the array images math routine, we recommend educators use the look, think, talk strategy. And honestly, this can really be used throughout the day in a classroom with multiple situations. So look, show students an intriguing image and pose a mathematical question. Think, give students a chance to think. Talk, engage students in a discussion about the image and questions. Here are some array image questions that a teacher could consider. And again, it's based on the student's age, the image you're using, how much time you have. But here are some of the questions you could choose from. What do you notice and wonder? How many are there without counting? That's what we're really pushing to. Now, some students might be just comfortable at this point counting, so we don't make them feel bad or shame them for any reason for counting. But we want to gently try to highlight the strategies that come from students that don't involve counting. That's where we're going to hover and give a little more time and energy to, because again, it's related to the subitizing, seeing groups of within a larger group. We might ask, can you see it a different way? What equation would match the way you see it? Is there another equation that would match the way you see it? And here's even a bonus question. If a student presents an equation that another student didn't come up with, can you push yourself to see how their equation also matches the picture and how? So once you get in the swing of doing this math routine, you'll come up with other questions too as they relate to the image. Let's look at one of these images. Depending on the age of our students, we might ask, especially if this was kindergarten, first grade, second grade, we might start with, what do you notice? So really, we're just entering, base level. Everybody in the room can be engaged because every child is going to notice something. Hey, Miss Brewer, I noticed there are dogs. Oh, I think the dogs are sitting on stairs. So we just want every student to be initially, again, we're just starting baseline, engaged. So what do they notice? Then you might and we're going to do this pretty quickly. We're not going to spend a lot of time on the what do you notice. The follow-up question might be, what are you wondering? Is it one family that has all these dogs? Where do they sleep? How much do they eat? Okay, so just give them a little bit of time to have that natural curiosity. What are your wonderings? Then we might get to, how many do you see? How do you know that? And again, we're not flashing this image. We let them look at the image. What equation would match the way you see it? Some students might say, I see 8 steps with 2 dogs on each step. So 8 times 2 equals 16. Okay, that might be a 3rd grade class, 4th grade, 5th grade. Another student might say, I saw 2 dogs on each of the 8 steps. So 2 plus 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 2 equals 16. The teacher can write the corresponding equations, maybe on chart paper nearby, or if this is displayed on an interactive whiteboard where you have the ability to record equations, I would strongly recommend doing that. All right, let's look at another one. Here's another array image. The teacher might decide that providing individual whiteboards with dry erase pens might be beneficial for this example. So the teacher's going to pre-think, do my students, would they need something to have access to this problem? Students would probably notice that the top row has 4 rolled items, and each remaining row below that has +1, +1 more, +1 more. So essentially, we end up with an equation that is 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. With this problem, students probably would benefit from some place to record their thinking. That's a lot of math to do, mental math in our head without keeping a record of it somehow. I'm not saying it couldn't be done, but it might. Having a place to record our thinking might really be beneficial and open up the range of students that are successful with this problem. A follow-up question could be asked if, again, depending on the age of the students and if we feel it's appropriate to challenge them that day. How many rolled items do you predict would be in the 10th row? Why? How did you figure it out? Here's another example of array images math routine. Notice the questions that could be presented for students to use with this image. So the superpower of the array images math routine is due to the nature of the questions, especially the first question on the slide, what do you notice and wonder? As I mentioned earlier, all students are going to be able to participate with that question, and it's going to initially get them engaged about the image. For this math workshop, let's examine one more math routine. Let's examine visual patterns. These are the visual pattern questions that teachers can choose to use. Some of them are similar to the last questions we just looked at. What do you notice? What do you wonder? What do you think you will see in the next step and why? That will make sense in a moment. Now that the next step is revealed, what do you think you will see next and why? How is the pattern changing? So let's look at an example. When using the visual patterns math routine, you will share with your students that they're going to be shown some steps in a pattern. Their job is to consider the questions that you choose to ask. So what do you notice? What do you wonder? And most importantly, the question we really want to hover around and have the most energy around is, what do you think you will see in the next step and why? We are looking at the first step in the pattern now. What do you think you will see in the next step and why? Here's the next step in the pattern. Does this represent what you predicted? What do you see happening from step 1 to step 2? How do you predict the pattern will grow for the third and final step? Here is the final step. Is this what you predicted? How has the pattern changed? Depending on the age of your students, they may be able to come up with a rule or statement on how the pattern is growing. You can challenge students to predict the next design. That would be the fourth step, or the 10th, or the 100th. So again, that's really age dependent design in this pattern. Here is the answer key. And in our examples that you can purchase from our website, we have the answer key for you for all of them. So in this growing pattern, step 1 has 4 blue squares, 1 purple square, and a total of 5 squares. Step 2 has 8 blue squares, 1 purple square, and 9 total squares. Step 3 has 12 blue squares, 1 purple square, and 13 total squares. So between the steps, we're seeing a +4, +4, +4. So the advanced rule for upper grade students would be, oops, sorry, I went too fast, 1 + 4n. Now, we do provide the answer key for you as the teacher, but I want you to hear me clearly. We're not suggesting you reveal the answers to the students. Again, the purpose of the math routine is to see what we get from students. So the answer key, it's not going to show up on a slide like this. I'm just doing this for this presentation. It will be in your notes that you will have, but it's just to help you facilitate the discussion if the discussion goes that way. Oh, Miss Brewer, I notice it's a +4 each time. And so you can have that information in the back of your head because you looked at the answer key, and you're going to be thinking about how am I going to record that? So maybe even drawing an arrow and doing +4, drawing an arrow +4. You, as the facilitator, you're going to be making those decisions on what should I record and how should I record it so that all my students in my class can get access into whichever student was sharing what they noticed. The awesome part about recording for students is that it really provides a link between that visual representation of the pattern and the abstract mathematics in the equation or in the table. And most students, honestly, are going to need that. Not all of your students, but it's really going to support most. I know I benefit from seeing the equations, the tables, matching what I see in the visual. It helps solidify my thinking. The visual pattern superpowers that are used in math help students develop a deeper understanding of mathematical concepts, build foundational skills, their problem solving, their reasoning. It's really laying the groundwork for algebraic thinking. We recommend that educators use talk moves as a facilitation strategy for promoting classroom discussions. These talk moves prove to be a game changer in promoting student agency. And I know the poster that is on display there says math talk moves, but here's a secret that you probably know. They can be used in any part of the day, any subject. So revoicing. Oh, so you're saying that you knew 4 plus 3 is 7 because you knew 3 plus 3 is 6, and you added one more. And it could be the teacher's revoicing, it could be another student's revoicing. Repeating is hands down my favorite. So here's how we recommend teachers use repeating. Not in a punitive way, which I have used this in teaching in a punitive way, and now I regret it. Johnny, can you repeat what Sally just shared? Oh, you can't because you weren't listening. Come on, Johnny. That's not how we recommend using repeating. Repeating is an invitation. Oh my goodness. Who heard Sergio's explanation of that visual pattern? Who heard it and can repeat it? Because that is worth repeating. And if no one heard, and we only use repeating when we think it's like a great idea, we do want to hover because we think, well, maybe a couple kids heard, but not everybody heard. So let's hover here for a minute. So then you say, Sergio, that was so awesome. Can you repeat that again? And then I'm going to ask again, I'm going to invite who heard what Sergio said and would like to repeat it. So I tell you what, our kids, most of them want to be talking. So if we're setting them up for success, hey, all you have to do is listen to Sergio, and then you can volunteer to repeat what he says. Then after that child, whoever you called on, repeated what Sergio said, you always go back to Sergio. Sergio, is that what you said? And, how did that kid do? And again, it's in a positive way. And because sometimes kids don't repeat what the child said, and Sergio can say, no, actually, this is what I said. And then you can give that child a second chance. Oh, okay. Can you repeat it now? So we're just really teaching kids there is value in listening to each other and to considering what each other says and being able to repeat it, to think about it. I honestly believe, and I bet you do too, students can learn probably more from each other than they can just from me, the teacher, because there's so many of them. So let's empower them with that technique. I love reasoning. That's the next talk move, and that's math routines are all about reasoning. Do you disagree with why? How did you see it? Why did you see it that way? Can you explain that? Adding on is a favorite too. Who heard what Christine said and can add on to it? I'm always surprised, even down in kindergarten, that students have something to say about what Christine just said. It's amazing, but I've got to remember to ask the question. Who heard what Joe said and would like to add on to that thinking? And of course, wait time, something all of us need to work on, me included, and our favorite turn and talk. To summarize, remember that math routines are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency, things we want from our mathematicians. They're honestly our favorite part of math class. We hear that from educators and students. Our hope is that you found this Math Routines Math Workshop useful in supporting you as you guide your mathematicians through math routines. We find math routines to be not only fun, as we've mentioned several times, and engaging, but extremely helpful in providing opportunities for our students to make sense of math concepts and develop deeper mathematical understanding. Again, laying that foundational groundwork for algebraic thinking. We have more information on our website that you see on the screen, themathworkshop.net, about these various math routines that you see on the screen and others that we didn't have time to touch on during this math workshop. So feel free to go to our website, locate the resources page, which is there's a snapshot on the screen of the of a smaller part of the resources page, and you'll find more information under math routines. There's more videos, there's examples. So thank you for joining us, and we hope you have a terrific school year. Thank you. If no one's told you today, thank you for what you're doing for our students. It makes a difference.